Hello dear students of class 9th, welcome to the second part of the topic of chapter 1. We are going to start the second part now. Okay, in the first part we have studied about the units, how we select the units, measurements, and in the second part we are going to start the units of length. Okay, means only the length will be measured, the smaller units, the bigger units, the comparative units, how we will select and how we will use. Okay, so come to the point, units of length. SI unit of length is meter. We already studied about in standard form SI unit system. What SI unit of length is meter, the standard or fundamental units of length. That is okay. In 1889, the scientists and the good minds selected a platinum iridium metals. Platinum iridium plate, which is an alloy of platinum and iridium. Okay, which is an alloy of platinum and iridium, in which 90% are platinum and 10% are iridium, because it has been made, this plate is made up of two metals, that is platinum or iridium, and the mixture of two metals is called as an alloy. So its metal, this plate is metal plate is an alloy. Okay, come to the point. In this alloy they selected some distance between 2 points. Okay, and they called it as a 1 meter. They called it as a 1 meter by keeping it at 0 degrees Celsius. Okay, International Bureau of Weights and Measure decided this. This is the organization which has developed these ideas. Okay, and after that, again in 1960. Redefinition of meter has been done. Okay, in 1960 redefinition of meter has been done. Okay, by using the radioactive substance, that is krypton 86. Krypton 86. Okay, in this metal emits, radiates alpha, beta and gamma. Okay, that is called as emission, or that is called as emission spectrum. You not able to understand that emission spectrum. Let us assume that we know that atoms have a nucleus. Atoms have many cells. As it is of higher atomic, so it has many cells. When electrons lose energy, the outermost electrons, the electrons present in the outer cell lose energy, they jump to the lower cell. Electron will jump to the lower cell. In this process, they emit a spectrum. Okay. That much length means 1650763.73. This much times the wavelength of orange red spectrum lying in the emission of a spectrum of krypton 86 gives an idea of what 1 meter. Okay. This was the basic definition which has been given in your books also. You may also read from that and able to understand this. The basic idea I have given how they selected 1 meter distance. Okay. Now come to the point, sub-units of meter. Sub-units of meter means we have selected 1 meter, this much distance will be called as 1 meter. How we will now convert it into the many units like centimeter, millimeter, micrometer. How we will convert it? Nanometer. That is called as sub-units for the measurement of a smaller units. Okay, because for measurement of minute minute things, very small particles, it will be tough to measure from a meter scale. Okay, so they converted it, they compare these smaller units to the bigger units and make a relation between them. Okay, then what is the centimeter? 1 centimeter is 100 part of a meter. Means 1 centimeter is equal to 1 by 100 meter. That is 10 to the power minus 2 meter. Okay. Similarly, 1 millimeter. 1 millimeter is 1 by 1000 times of a meter. Okay. That is 10 to the power minus 3 meter, or that is also called 1 upon 10 centimeter. Okay. Now come to the point. 1 micrometer. 1 micrometer is a 1 millionth part. Okay, 1 millionth part. That is 1 micrometer is called as micro. This is the symbol of micro. Okay, 1 micrometer is equal to 10 to the power minus 6 meter. Mu. We also call it mu, micro. Okay, come to the point. One I also explain you. 10 mm, 10 millimeter is equal to 1 centimeter. How I have made this? How I have made this? I have made from this. Okay, 1 by 10 centimeter is equal to 10 mm. You have simply to multiply this 10 with this mm. So 10 mm is equal to 1 centimeter. Point to be remember this. Okay. Now the next point is nanometer. Nanometer means 1 billionth part of a meter. 1 billionth part, that means 1 nanometer is equal to 10 to the power minus 9. 10 to the power minus 9 meter. Okay. Now come to the multiple units of a meter for measuring a bigger length. Okay, bigger than a meter. Okay, for measuring the distance between two places, two cities, we use this. Okay, kilometer. That is 1 kilometer is equal to 1000 meter. You have to remember with this. Now the bigger units means which cannot be directly measured. We can only imagine that. We can only have typed that this much distance will be. Okay. For example, measuring a distance of a star from Earth. It's very difficult task. Okay, which cannot be really measured. It can be calculated by some selections point. Okay, come to the point. Distance between two heavenly bodies. You will go to the heavenly bodies and measure that distance? No, you will use mathematics to measure it. Okay, astronomical units. Astronomical units means first unit in bigger units is the astronomical units. Astronomical units means the mean distance between Earth and Sun is called as astronomical units. The mean distance between Earth and Sun means average distance between Earth and Sun. Okay, it's called as what? Astronomical unit. One astronomical unit is 1.496 into 10 to the power 11 meter. That is in plus 10 to the power 11 meter. It is 1 astronomical unit is equal to 1.496 into 10 to the power 11 meter. Okay. Light year. Come to the point. Light year. Light year is a distance traveled by light in 1 year. Distance traveled by light in 1 year. Simply in vacuum. खाली स्पेस में प्रकाश के द्वारा एक साल में कितना डिस्टेंस कवर किया जाता है, that is called as light year. So it is simple to calculate how much distance will come to the 1 light year. That is, we know that distance is equal to speed into time. So speed of light into time, we multiply it, that will become 1 light year. 1 light year is equal to, we know that speed of light is 3 into 10 to the power 8 into time in 1 year. Time in 1 year, how we will calculate? We know that there is a 365 days. There is a 365 days. Okay, in a year and 24 hour in a day and 16 to 16 second. Okay, so we will simply multiply this and we will get 1 light year is equal to 9.46 into 10 to the power 15 meter. That is equal to also 9.46 into 10 to the power 12 kilometer. You know that because 1 kilometer is equal to 10 to the power 3 meter. So we have removed here from, we have decreased 3, 10 to the power 3. We have decreased and it becomes 9.46 into 10 to the power 11 kilometer. Okay. Now our next unit is parasec. What is parasec? Basically, come to the point, parasec. I am explaining you. Yeah, it is too tough. Parasec is basically arc length between the 2 points. Arc length between the 2 points such that it's a semi-major axis. Semi-major axis makes 1 second, angle of 1 second. Okay. Parasec is a basically distance, arc length. This is arc length. This is angle of 1 second. We will make angle of 1 second. This will be the radius. You may say that, or okay, and this will be the what angle, radius, arc length. Okay, this arc length will give you the what called parasec. Come to the point. How we will calculate the parasec unit? Okay. 1 parasec wavelength upon angle in radian. Okay, that is arc length is equal to 1.496 into 10 to the power 11. That is 1 astronomical unit. Okay, if we will take arc length of 1 astronomical unit and angle made by 1 second, then the radius, distance of radius will be called as parasec. Okay, that much distance is called as parasec. That is calculated by 1/36 into 5 upon 180. That is in radian. Okay, you know that 5 radian is equal to 180 degree. Okay, that's right. In 1 radian is equal to, or 1 degree is equal to, 1 degree is equal to 5 upon 1. Okay, that is equal to, you have to only remember that 1 parasec is equal to equal to 3.26 light year. Another combination is also you have to be within your mind that 1 parasec is equal to 3.08 into 10 to the power 16. Okay. So there is a 2 units also we will discuss, that is very small unit, that is angstrom and Fermi. You should know that angstrom and Fermi is very small unit. Fermi is used to measure the diameter of a nuclei, atoms nuclei's diameter is measured in a Fermi. Okay, and angstrom is a very small unit, that is 10 to the power minus 10. 1 angstrom is equal to 10 to the power 1 angstrom is equal to 10 to the power minus 10 meter. This is your mind. Okay. And the next 1 Fermi is equal to 1 Fermi. Fermi is equal to 10 to the power minus 15 meter. Okay. Here we have done the only relations between meters and bigger units, smaller units. Only we have managed what will be the relations between meters and bigger units and smaller units. Okay. In the next class we will talk about mass. Okay, thank you.